Hello everyone, welcome back to my channel. I am Udit, and today we have all seen, the outage that has happened. Whether you call it Microsoft outage or you call it, CrowdStrike outage, whichever outage it is, but it's a global outage, right? And in this video, I'm going to actually talk about how can you build your systems to prevent global outages, right? I'm not saying that whatever we are going to discuss today, Microsoft did not do it, or CrowdStrike did not do it. There are some misses many times that happen, because of which these outages happen, and in a really bad day these things you might end up into. But obviously, I mean, as a software engineer, you should try to avoid it as much as possible, and that's what I'm going to discuss in my video today. How can you do that, and different strategies we'll see. It actually all boils down to mainly deployments. How can you do deployments in different ways whenever you are sending a new feature, whenever you're sending a new update. How can you do it in a way so that it does not break anything existing, right? That's what we are going to discuss. How can you achieve all of that stuff? Before even going into the actual video, I want to talk about the course which I've been doing for some time on both LLD and HLD. So it's like a very hands-on course. We discuss things right from scratch, end to end. In HLD, we start from building services. We start from a very basic service, handling so many things, and then we try to break it down into small pieces, understanding the problems, why to make a particular decision, why to divide service in a particular way, why to introduce caches, why to introduce a queue. Wherever we introduce anything, we first discuss the problem and then we come up with a solution. Similarly, in the low-level design. So if you're really interested into understanding how to design systems, both in terms of low level and high level, in a very scalable, extensible manner, and also understanding from the practical perspective, how do you go about them, feel free to register for those cohorts. I will put those links in the description of the video. Let's directly jump into the video now. So as I said, right, like global outages, what do they mean? They mean everywhere, right? All everywhere in the world things are down, right? Let's consider a very normal scenario. Let's say you're working on a backend system and you're going to deploy some changes. Let's say you have built a kick-ass feature, you are going to deploy it today. Now, if you're going to deploy to the whole world today itself, then obviously, if there's a bug, if there's an issue in the feature, then people will face the issue, right? I mean, it will break the things, it will break the systems. So if you deploy to the whole world in today itself, anywhere who is using it, let's say somebody using it in USA, somebody using it in India, somebody using in some other part of Asia, anywhere, right? Whoever gets the update, will face that issue, right? So our goal is actually to reduce, right? Reduce the, what do you call, I mean, technically we call it blast radius. Okay, so our goal as an engineer would be, how can we deploy a particular update, how can we deploy a particular system in a way so that the blast radius of the change, because you're sending a change, right? Now, if it impacts something, if it introduces a bug, then the whole thing is impacted, right? Like whoever gets the update, they will be impacted. So the goal of an engineer is to reduce this impact by reducing the blast radius. And the whole video is about how companies like, again, big companies also where I have worked, Microsoft, Adobe, Amazon, these kind of companies. Similarly, even smaller companies I have consulted. I'll talk about how they do it in different ways, and that's the whole video is about. So the goal, again, I'm just reiterating, the goal is you have a, instead of deploying in the whole world at once, how can you deploy it in chunks? That's the idea, because if you deploy everything together, obviously, I mean, if there is an issue, the whole world will get impacted. So the goal is, let's deploy maybe smaller chunks, let's deploy a bigger chunk later on, then we will deploy even bigger chunks. So it's like slice by slice, keep deploying, and that way you will have less impact, right? Obviously. So there are two ways of I would say this control. You're sort of controlling your deployment, right? So what do we really mean here is we are saying we are controlling our, you can call it release, you can call it deployment, right? So we are controlling our release or deployment in maybe maybe chunk by chunk. So that the whole world is not impacted at once, right? Now there are two ways to do it at a very high level. One way is through a feature flag, okay? And another way is, deploy the code only later on, right? Deploy the code, or we can say limit deploying the code, okay? So I'll explain what do I mean by each one of them. So let's take an example. Let's say we are building Microsoft, and Microsoft is having a feature in the Word. Let's say Microsoft Word, we are working with, and we are building a new feature. Let's call it feature X. Now Microsoft doesn't know, right? Like whether the feature X, first of all, is there any bug or not. Obviously, you can have some testing and all, but again, at the end, you can always skip a test case, and you can always add into bug in production. So I'm not saying you will not put testing in your pipeline, or before releasing you will not do testing. You will always do testing to pick up the bugs or to figure out bugs. But in the worst day, you can still end up with a buggy deployment, and that's why I think that's what happened with Microsoft or CrowdStrike today. And we are trying to avoid that kind of a situation by going even a step further. So let's say Microsoft is trying to deploy a new version of Word, which is, let's say, X feature, and they have done all the testing and everything. Now when they are doing the deployment, obviously there will be servers, right? That is server number 1, server number 2, and so on up to server number n. Okay. Now one of the ways, you put your feature behind a feature flag, okay? You put your feature behind a feature flag. That's why it is called a flag, meaning it is a dynamic flag which you can update at runtime. And when you deploy it, you keep it false, okay? During the deployment time, meaning you have not released it yet, right? You have just completed the coding. You have done testing. Now you are deploying it, right? So during the deployment, while you are doing the prod deployment, you keep the feature flag value as false, right? Now once the deployment is done, and one more thing you will do is, you don't worry whether it's deployed on one server, it is deployed on 2 servers, or it is deployed on n number servers. So slowly you will deploy on all the servers. Again, we'll come to how can you deploy in different way on the servers when we talk about code based, when you try to limit your code deployment itself. But right now what we are saying is the same code is actually going to deploy on all the servers in one go itself, okay? So all the servers that you have S1 to Sn will have the same code at the end of the deployment thing, right? With a feature flag as false. Now what will you do? You will control your release. So what will happen? Let's say if I am the user of Word, I will get this new update, but there's nothing changed in my application or something, right? Whichever I am using. But the point is, I have got the new binary. So that means I have got the new code. So if I open Word, the code that will be running will be the updated code. So let's say if the version of the app, let's say, before deployment, it was the version 1. After deployment, it is the version 2. So the app has updated. So code containing new feature is there on my app now, right? So code is there, right? But because the actual feature is in feature flag, so whatever the entry point of the feature, let's say if it is a some button, something, then the button will be hidden, or something else, whatever the feature is, depending on that, whatever the entry point generally you have, that will be hidden, and that will be controlled by the feature flag. So I'm still able to use the app with a new code, but nothing changes in the functionality, and that's what you call as a feature flag, meaning the feature flag is disabled, and by having that disabling feature, you are still able to release your code without any impact to the users, because your users are not able to see it. But when you try to release, okay, now when you want to release the feature, because obviously you have developed the feature to make it available for the users, right? You have to get the business. So when you release the feature, now you don't have to do any deployment. What you do during the release time, you turn on the feature. Right, you turn on the feature instead of again doing the code deployment, because the feature is directly there, right? You can just turn it on and it will be available again to the users. What you can also do is, instead of turning it on for everyone at once, you can do multiple things. You can do, okay, I'll turn it for first of all my beta users, then maybe my some another group of users, and then if let's say after beta users I will monitor for some time, and if let's say things go bad, then I will again turn off the feature, because I know the metrics are going towards the wrong direction. Let's say latency increases, or errors increase, whatever the metrics you are targeting. Obviously you will be monitoring some of the metrics. So after enabling it for some set of users, let's say your beta users for 5% of the total number of users, so after enabling for the 5% of the users, you will monitor for maybe a day or two or maybe a month, and then you will see what are the results. If the results are in a positive direction, then you will continue, and after the beta, maybe you will, after 5%, maybe you will say I will deploy now to 10%, then maybe now to again monitor, and then again you will do 25%. And then 25% you can say, okay, it's a sufficient confidence I have got, because if for 25% it is working, then maybe I will deploy for 100% of the users. So this is one way of doing it. Another way of doing it, maybe you can say, okay, I'll first deploy for free users, because obviously sometimes free users are considered to be low priority, right? Like if somebody is paying to you versus somebody is using it for free, obviously free users are, if you break something for them, maybe it's less harmful. Obviously it's harmful, I'm not saying you can just go ahead and break for them, but it's less harmful to break a free user. But definitely you would like to provide a better experience to the paid users, and that's why sometimes what you can do, you can just deploy for the free user and then see how is it performing, and then you deploy for the paid user. That's another way, right? One more way you can do is, let's say you are something like maybe Ola kind of a company, right, where which is more primarily located in India, but let's say Ola also has some offices or some business in outside India, or vice versa, right? Let's say Uber has primary business in US, India just started and it's a small business. So what you can do, you can deploy in non-priority region. Deploy as in, deployment is done, you can release, you can enable the flag for the users in the non-priority region, meaning again, if for Ola, let's say Singapore is not a priority region, so they enable for Singapore, and then again what they do, they monitor, and then they continue the process for more number of users. So after let's say Singapore, they do it for India directly. So because they've already tested it for more number of users, so and they know things are working pretty fine for Singapore users. It's a good set of users, so things will work fine for India also. So that's another strategy. So point is, what we are really trying to do here is we deployed the code at once. Okay, so everybody has the code, but the enabling of the feature, right, the enabling of the code we are doing from the backend, and we are saying we'll do for a small set of users first, then more. Now whichever strategy you want to use, whether beta kind of strategy, free, paid, region based, or something else, that depends on application to application, company to company. Everyone has different strategies. Some I have even mix up also. Let's say you can say, first I will deploy to free users, then I will say 5% of paid users, then maybe 25% of paid users, and then 100% of paid users. That is also a very common strategy people do. So any mix and match you can do. The goal is you are trying to increase the confidence before enabling the feature to the 100% of the customers, to make sure the thing that you are releasing is actually not breaking anything, and actually it's improving the product, or achieving the goal, actually whichever you are trying to achieve by the feature, right? So that is one way of doing it. The problem in this way is, as you could have thought about, is because we are deploying the code, right? And as we have deployed the code now, what if the feature flag itself has a bug? Let's say you by default, by mistake, the way you added the feature flag was not correct. That's one, right? And or maybe even after adding the feature flag, let's say you introduce some bug, so it's more error prone, right? More error prone as in, actually you're deploying the code, right? And it can break. What if, let's say, some unwanted change in, you got into the code? Obviously there are ways to avoid all of those things, but the point is, on a very bad day, all of these things can happen, and that's what we are trying to avoid. So that's why we're trying to see what are the pros and cons of different approaches. So here, though we are not enabling the code for the user, but still we are sending an update. We are sending the updated code to the user. So still there can be some logic before the feature flag itself, which can break before the whatever the code flow you have turned off. Maybe at that point you have a bug or something. Obviously the chances of that is lesser, but it's still it's not zero, right? There is some percentage that can also happen, right? So that's why this way of controlling the release has a little problem, which is you are able to still send a buggy code to the user. But the pro is the control is really good. Maybe you can even control at the user level, at a region level, at a property of the user level, like free or paid. So a lot of things you can do. So the configurations, I think the control actually that you get in this kind of strategy is very strong, is very good, with a small con that because you're still sending the code to the user, the code can break, right? So and you can land into trouble on a very bad day. Now talking about the another option, right? The another option is, as I said, limit the sending of code itself. Okay, so yeah. What is second option? Second option is limit sending code. Now what happens here? So as the name suggests, as the title suggests, in this kind of mechanism, we are not even going to send the code to the user. Okay. The pro is, I'll explain the solution also, but let me tell you the quick pro. So the pro is the con of the other one. So pro is because user not even getting the updated code. So no issues can happen, right? Yeah. So here in this solution, what happens? You will not be even sending the code to the user. So for example, let's say if I am the user, or Ola is making a deployment, or Microsoft is making a deployment. So I'm not even getting the updated code. It's the same code which I have been using so far. So I'm good, right? I will. Because there's no chance of break, right? Obviously, if the previous release has a bug, I'll continue facing that. But the new things which they are sending, whatever bugs they will have, I will not be receiving them, right? Because I'm not getting the new thing, right? That's a pro. But the con is again the reverse of the pro of the other one, which is the control is lesser, and I'll tell you why. Okay. Cool. So now, how does this work? Is so let's say again you're deploying things, right? So let's say again you have S1, you have S2, you have S3, and so on up to Sn. One way is you go and deploy to each one of the server at once, right? You just, let's say you would say trigger deployment, and there is a job that you started to trigger deployment on all the servers. Okay. Then what will happen? In such kind of cases, actually you don't do deployment on all the servers at once. Why? Because okay, let's take a step back. So how will you do deployment? So basically point is, what you want to achieve, you want to update the application over here. So here, let's say v1 is running. What you want to transition? You want to transition to v2, to v2, to v2, and to v2, right? And to do that, what you really have to do, you have to stop v1, correct? So when we say stop v1, now v1 cannot take any more requests, right? And if v1 cannot take any more requests, that means that's a downtime. Obviously, you cannot have downtime also, right? When you're deploying things, you cannot have downtime. So I'll again tell you how this is achieved. But the point is, when you are updating v1 to v2, what you have to do, you say stop v1, replace with new binary. It can be anything. It can be an exe file. It can be a jar file in case of Java, whatever. Whichever binary, whichever application you have, you will replace that one over here with a new version, right? Now what will you do? You will start, because now you have v2, right? You converted it to v2 with new v2 binary executable file or jar file, right? Now you will say start v2 again. Now this process can take minutes, multiple minutes. Sometimes it can take 15-30 minutes also. And obviously if you start this process at all these live servers, these are all live servers, right? S1, S2, S3, S4, SN, these are all taking requests. So if you start this process together at all of these live servers, things will go down, right? I mean, your users will not be able to send any requests, and there will be availability issue. Your system will suffer from downtime. Some companies might do it, maybe startup or somebody who is fine with downtime, they might do it. But obviously, if most of the companies who are not fine with this downtime, they cannot do it, right? So how do you solve this? What we do is, there are two ways to solve this. One way is blue-green. There are two standard ways people use. One is called blue-green deployment. Another one is called rolling deployment. You can also call it incremental deployment. Okay. Now, what does blue-green means? What we do is, whatever number of servers we have in the production right now, whichever fleet we are deploying. Let's say your cluster has 100 servers. What you do, you bring up another 100 servers, okay? And then, because you have not touched the original fleet yet, right? So let's say this is your original fleet. It is running 100 servers, right? It is running the application number v1. Now what you do, you bring up another fleet, the same fleet. You will create a copy of the fleet in terms of the servers. You will again bring up 100 servers of the same configuration, same type, everything is same. Obviously plain servers, right? Nothing is deployed on them. So 100 plain servers you will bring up, and now you will deploy the v2 application on these new servers which you have got, okay? Once the health checks start passing on this, on this new fleet, on these new servers. I mean, what is health check? Health check is a mechanism, to make sure the servers are healthy and they are able to accept requests now. Maybe I'll create a separate video to talk about health check in detail. Maybe you can Google also, it's fine. It's a small thing you can quickly learn about what is a health check. But the point is, what do I really mean by health check here is, like, the server is ready to take the request. So the new fleet that you have bring in, the new servers that you have brought, they are able to receive requests now. That's what we are trying to say. Now what will happen, because the new service is also ready to take the request, it's a complete copy, right? Now at the gateway layer or some other level, the live traffic that you were sending to this previous set of servers, now you will switch it, you will stop this, and you will start sending this to the new set of servers, right? This is what is called blue-green deployment, meaning that's why the name is, like, there's a blue fleet and then you bring up the green fleet. At a time, all the traffic is being sent to one of the fleet, either blue or green. It is not like, half to blue, half to green, not like that. That's why the name is called blue-green deployment. You have one fleet already with you, which is serving the live traffic with the old application version. Now you want to deploy the new application version. What you do, you bring up the same set of servers in a different cluster, and then you install the new application over there. You route the traffic completely to the new application. That's how this blue-green deployment works, okay? I hope that is clear. Instead of blue-green, another option is there is a rolling deployment, okay? In rolling deployment, what you do, you have the live servers, right, which are taking the request, right, with the v1 version of the application, right? So let's say you have S1 to SN. Now what you do, instead of, because if we stop the application on all the servers, then it's a problem, right? So instead of doing that, what we do one by one. So what we say, we first of all kill application on S1, stop S1, stop v1 on S1, then install v2, and then start v2. Okay. Once this is done, this is completed, S1 is now serving v2. Now we go to S2. Then S3, then S4. So that's why the word called rolling or incremental, meaning instead of doing all at once, you are doing in a rolling mechanism, in an incremental fashion. One by one, you are taking the server and updating the application on them. And this will ensure, your whole fleet is not down when the deployment is happening. Only one of the server is down, or maybe, I explained it that, okay, one at a time you take for the deployment, but actually it can be very different. You can also take 2 servers at a time. You can also take 3 servers at a time. How many servers to take? It actually depends on the buffer that you have, because when you take some of the servers down, obviously that kind of load will also be there, right? And that load will start going to the rest of the servers. So let's say you had overall, let's say each server was getting 100, and you had only maybe 50 as an overall buffer in the system, right? Then when you stop it, your rest of the fleet will not be able to handle 100, right? Because only 50 was the buffer. So depending on how much buffer you have, so let's say if you had overall system, let's say has 500, right? Then maybe you can take down 5 servers, but maybe you will not take down 5 total. You will maybe start with 3, that okay, there might be some other issue that might come up, and for that you might you might want to keep 200 bandwidth for it, and that's why you will say I will bring down 300 bandwidth at a time, and that's why you will say I will keep bringing down 3 servers at a time, and keep updating 3 servers at a time, and that's how I will update the application in a rolling fashion. Cool. I hope these two ways are clear. Now obviously the pros and cons of this kind of architecture, of both the architectures are, in this kind of thing, it's like all at once, correct? So it can lead to definitely global outage, right? Meaning you are deploying, you are just switching the whole traffic at once. So whatever the topic we are discussing today can happen if you are having blue-green kind of deployment. In rolling, after deploying to one, maybe you can wait for some time, and you can see is it working fine, and if it is working fine, then only go to 2. Similarly, after deploying on 2, you can again check the monitor for both the applications, and then you can again keep on deploying incrementally after only verifying your monitor. So if something bad happens, your rest of the fleet will still be working fine, only one server will be down, only one server will be having the downtime or the issues. So whichever users, we are not sure which user will come to which server, whichever user come on S1, they will start facing the issue, because S1 will be having V2, all the other servers will be having V1. So whoever comes to this server, because this application has a bug, so they will face issues. So there will be some degradation that you will be having in terms of the users impacted. But obviously maybe this is maybe your 95% of the user, this is your 5% of the users, so 95% of the user will still be able to get the work done, but 5% will be having some issue. So the impact will be lesser. The blast radius you were able to reduce by just deploying incrementally on the servers. That is one of the very important benefit of it. Okay. Second benefit here is, second problem first of all in the blue-green is the cost, because you are bringing up the full fleet of 100 servers at a time. That can become an issue at a time. I mean, let's say your deployment is overall going on for, let's say, 1 hour or 2 hours, so you're bringing up new fleet for 1 hour, 2 hour. Obviously it will increase the cost, right? That's one problem. Second problem at times is cloud providers at times they are also not able to provide you these many large number of servers if you just request them at once. At times that can lead to deployment issues, because they do not have that many servers available in the infrastructure fleet at that time. Okay, that kind of problem is not going to be here, so it is cost effective, and these cloud provider issues, they don't happen over here. What is the benefit of the blue-green? Obviously it is if you have backward incompatible change, you are good here. Why? Because all the traffic is sent to one fleet at once. It will not be like let's say your first request comes over here, next request comes over here, then it will be a problem, right? Because the first request interacted with V2 application, second request again interacted with V1 application. So if you have backward incompatible chain and those kind of things, then it will be a problem. So backward incompatibility will be an issue. So if you're sending a change which is going to conflict with the current behavior of the application, that means it is backward incompatible, and that's going to create a problem if you use a rolling deployment. But if you use a blue-green deployment, then that will not be an issue, but obviously there will be other issues that you will have, right? The time of deployment will be lesser here, right? Because you can start deployment on all the servers parallelly, right? So let's say if each server takes some time, let's say 10 minutes to deploy, so overall deployment can finish in approximately 10 minutes or so, some few minutes here and there. But here because you're taking one by one, so let's say if you have 100 servers, each server is taking 10 minutes, so obviously you will have 1000 minutes of deployment time, right? Obviously, as I said, you will not do one by one. You will pick up some set of servers and then stop the application over there, and then bring up the new application over there, right? So maybe you can reduce the time by that, but the point is, in rolling deployment it takes time, while in blue-green deployment it takes lesser time to complete to finish the deployment. But the point is, these two things you can control, the time, the more time thing, or the backward compatibility or cost effectiveness, all of these things, backward incompatibility and time kind of thing, you can still solve for rolling kind of deployments, and it gives a very good benefit that okay, cost is effective, but even more benefit is the blast radius is lesser for this, right? So that's why a very popular deployment strategy that we have, that people use, is rolling or incremental, because it gives a lot of benefits, right? And increase of time, people try to increase their deployment times by reducing the starter dependencies of the service, or they also try to reduce by increasing the number of servers being deployed at times, by increasing the window, or rolling number of servers that you have in a particular step, right? So at a time, how many you are deploying, people try to increase the number of servers of those things so that they can deploy faster. So those kind of things people try to do, but the benefit which you get, that outage you can prevent, that is a very strong benefit, and it's important to have. Cool. So that's like a single service or one service you're talking about. Obviously, if you're having multiple services, the same thing will be applied to each service. That's one thing which I talked about. Now, let's say if you are in let's say you are deploying in India. Let's say you have 50 servers in India cluster. Then obviously the strategies that we discussed, blue-green versus rolling and all, you can do that, right? But what else people do? Okay, one more thing actually before I go over there. As you see, what is the control that we have? The control we have is only the server, right? While in the previous one, the control that we had even the user level. So that's why, as I said, like in the feature flag based deployments, the control is very fine grained, is very even up to a user level. You can also do a property of a user, like as I said, free user, paid user, and those kind of things. But in the code based limit that you do, you have limited choices. You can only limit the server on which it is being deployed, and all the calls that go to the server will get the same experience. So you can do some tweaks, like we can say if there are some P0 flows, there is one cluster for it. If there are P2 flows, there are another cluster for it. So those kind of tweaks you can do if you want to prevent those kind of things. Like even in recently, like last 2 weeks only, I was reviewing one of the document, and that was an RCA which we got, and in that RCA the same issue was there. Like there was a P2 flow which actually for which we made a change, and because of that P0 change got impacted, right? So you can actually separate your cluster so that P0s are served from one cluster, P2s are served from another cluster. So those kind of things are different. But considering you have one cluster, so the impact you can only limit to a particular server. And that's the I would say little con of this particular way. But the benefit is even the small edge case that code getting a problem, or your code getting an issue in the feature flag itself, that can also be solved if you do this kind of deployment, right? So one more thing I would explain, which people do. Okay, so there's one more thing you can do is you have you can do region-based deployments. Okay, and this thing actually, I think everywhere I worked, whether it's Amazon, Microsoft, or Adobe, everywhere we used to do it. So generally what people do is general pipelines of people, how they look. Let's say this is your build pipeline. Okay, build pipeline meaning it takes the code in the input and takes out the executable file, which is jar in case of Java, right? Or maybe if you have a Docker, you will get a Docker image, right, as an output. So whatever it is, you will get some executable which you will be able to run on your server directly. Now this is your build step. Now the next step you will have maybe your dev box. Again, what all boxes you will have, that all depends on your CI/CD setup. Each stage, dev stage, build stage. Sorry, this is not build. Actually, this is beta. Beta stage, build stage. You can also have QA stage. Whatever number of stages you have, you can also have UAT stage. Each stage has its own meaning. I won't go into the detail of it because it will unnecessarily increase the video. Video size. I will maybe talk about different stages of CI/CD pipeline in a different video altogether. But the point is, your jar, your executable comes up. You deploy it on dev, beta, QA, UAT, meaning you complete all of your testing that you wanted to do, right? Then what you do, you deploy on region 1. Okay, so let's take an example. Let's say let's say you are very focused on maybe India, US, and these kind of countries. Let's say China is not your, let's say, focus area for the business, right? So what you do, you first of all deploy in China. Then again you monitor for some time, because the number of servers will be different, right? The cluster might be different for China. If you do not have a different cluster, then you cannot do anything about it. I'm assuming here you have a different cluster for China. So you have one cluster for China, you go and deploy over there. Then again you monitor for some time. Okay, how much sometime, again there is no definition of it. You can say 1 hour is fine, 2 hours is fine, 1 day is fine. It also depends on the change. Maybe also depends on the blast radius of the change. If the change is very tricky, very risky, maybe you want to wait more, you want to monitor more. If the change is little lesser risky, you can monitor for lesser time. It all depends on a lot of factors, but the point is you will monitor for some time. After monitoring, then you will deploy on second region. Let's say second region is Japan. Right now, after deploying on Japan, again you will do the same thing. Then you will deploy in India. Then monitor. Then you will deploy in USA, right? And also one more thing, you will deploy in the silent times of all of these regions. Let's say China, whatever the silent time means, like night time of that country, right? Or of that region. So whatever the night time of that China, maybe, whatever time it is, that time you will deploy in China. Then you will monitor the night time of Japan, night time of India, night time of USA. So that's how generally the pipelines look like, and why this way, you are able to again control your change region by region. Not here we're not using feature flags, right? Here we're saying the whole China region itself is not deployed, and the change is only in UAT, or maybe you can say the India is not deployed, the change is only in China, and we are going to monitor for some time, or the change is in Japan, wherever, right? The whole region, the cluster itself is not deployed, and that's why the user is not impacted, right? And now in each of the region, obviously what I explained previously, you can use blue, green, rolling, whatever you want. So it's not like this region based versus rolling and blue green. It's like both you can do together. It depends, right? Let's say you have a single cluster for the whole world, then obviously this kind of thing does not apply to you, because you do not have separate clusters which you can deploy. Let's say if you're working on a team which has different clusters for different regions, then obviously you can combine this strategy along with the previous rolling strategy. Or you can combine actually this strategy with feature flag strategy also. So it's not like one way or the other. Everything you can combine together to come up with a hybrid approach of yours. What I'm trying to tell you here is there are different ways of doing it. What really applies to you depends on the use case that you have. Right. One more thing I would like to talk about is, which is very similar to rolling only. Sometimes what people do is, even before starting rolling window, what they do canary. Okay. Again, it's very similar to rolling only, but sometimes, because in rolling, you are actually doing deployment one by one, right? Here, what you do, you deploy to a subset of servers. So basically, you deploy to subset and then you deploy to all at once. That's kind of architecture it is. In rolling, like one by one, you keep on doing it and keep monitoring, I would not say at every step, but maybe, at some steps, maybe you will test by doing one deployment, then maybe after 20%, then maybe after 50%. So that way you can test in rolling one. But here in Canary, what happens is, first you deploy maybe, 5 servers. Let's say you want to use blue green, right? Then what you do, you will first deploy to 5 servers, and then you deploy all at once here. And when you deploy to 5 servers, you send your actual prod traffic over here, and then obviously you will monitor over here. And once monitor says everything is fine, then you will deploy all at once. Otherwise, you will roll back the deployment. Similarly over here, if you find issues, you will roll back the deployment from here. Similarly over here, if you find issues after deploying to 2 or 1, you will roll back the deployment. So the goal here is, point is, there are various ways we discussed, various things we discussed. The goal here is, instead of deploying to everyone in the world at once, we are trying to control or limit the number of users who get the new change, new update, either by logic in the code or by not sending the code itself, right? These are the two high level ways, and in detail we talked about different implementations of them. Yeah, this is the crux of it, and this is how people do it. I'm not saying Microsoft did not do it today or CrowdStrike did not do it today. They must have done something. Maybe I think there's some miss that might have happened or something like that. But if you are asked this question in your interview, or even if you are going to implement something like this or facing this problem in your company, obviously these are the ways that you will use to solve this problem. I hope you enjoyed the solution and the discussion that I just did. And if you like the video, please do like and comment and share it with your friends. And definitely, if you want to go more into the details of the system design, how these things are actually implemented, how they work behind the scenes, feel free to join the cohort that I talked about in the beginning of the video. I hope I'll either see you in my cohort or in the next video. Till that time, bye bye. Take care.